All right, gang, Math 5500, more on multiple regression. The purpose of this video is to just expand a little bit, build our toolbox of multiple regression techniques. Impress upon you that multiple regression is the greatest thing since sliced bread. Okay, maybe not. All right, so the previous videos we've been introduced to multiple regression and a little bit of the theory, very little bit, and how that the simple linear regression techniques that we learned, especially specific to R and, specific across the board, are a adequate foundation for transitioning into multiple regression. So the first order model that we have is just exactly what we would expect. Instead of just having one predictor, we have multiple predictors. So this form is clearly equivalent to that form. Now, in a previous video, what I talked a little bit about is how we interpret these the coefficients. So this would be my estimate for beta 0, this would be my estimate for beta 1, that would be my estimate for beta 2. Now, we talked a little bit about keeping something constant. So, for example, if I was going to interpret the coefficient here for triceps, I would say holding thigh constant, holding all the other variables in the model constant. As we increase tricep 1 unit, the predicted body fat increases 0.22. Obviously, if this was negative, it would be as we increase tricep 1 unit, again, controlling for all this stuff, increase 1 unit, the predicted body fat would decrease 0.22. But it's not, it's plus. Now, what does that really mean? What that really says is, let's just think about setting a thigh measure. So, I don't know, whatever. Let's just say we set it constant at a 50. So anyway, that would just become constant, right? So again, holding constant, the other predictors in the model, then we can see that increasing the tricep 1 unit would produce a 0.22 increase in the predicted body fat. So that's what we mean by holding something constant. We're putting a particular value in there, in this case for a thigh, and then we can just focus on the change in tricep. So nothing more, nothing less. So enter in qualitative and categorical predictors, and I think the great thing about multiple regression is we now aren't restricted to just a quantitative predictor. Now, you may argue that, well, even a simple linear regression case that you could predict maybe body fat from gender, if you so want. I don't think that would be appropriate. If I had a quantitative variable that I wanted to explain over a dichotomous variable, then I'd use a t-test. Either pooled or unpooled, and you'll learn more about that in 6610 and 6620. But if I'm trying to predict, I'm not necessarily going to predict a quantitative variable from a qualitative or categorical predictor. So let me set the stage, what's to come. We're going to start looking at introducing qualitative predictors. And the first thing I want to do, this is what I'm going to do in this video once I transition over to R, is I'm going to look at how we handle a dichotomous variable. Now, dichotomous just means it's categorical with 2 levels. Succeed, don't succeed, survived, didn't survive. Again, something with 2 levels. Categorical, I define as something more than 2 levels. So, political party affiliation. Race is something that would probably have 3 or more. Again, just depending on the way that it was set up. Now, let's take a look at possibly a dichotomous variable, gender. And some people may argue that the way we define gender today is not dichotomous. I'm not even going into that. As a statistician, as a data analyst, what I do is I analyze the data that people bring to me. And I had a situation just yesterday where some occupational therapy folks had some data they brought to me, and they defined gender as male and female. So I analyzed the data as it was brought to me. Nothing more, nothing less. So this is in the spirit of the data that they brought to me. So what we would have is we would have our data set, which again is we would have n subjects. We would have a dependent variable, and then we would have multiple predictors. So in this case, we would have M's and F's, and it'd be a very straightforward analysis. Now, pump the brakes a little bit, and again, let's think about what we have with a standard data set. If we read left or right, we have information on cases, don't we? And a person who isn't trained in statistics and statistical analysis will typically look at a data set and read left or right, because that's where the juicy gossip is. We can come down here to the 41st person, and we can find out their measure on their body fat and their thigh and their their gender, all that. We can find something about that person. Statisticians don't do that. We could care less. We could absolutely give a crap less about what goes left or right. When I look at a data set, I read vertically. What do we have on the vertical? Well, we have our variables. I'm naturally led to, well, what's the mean? What's the standard deviation? What's the histogram shape? Are there any outliers for the y? Same thing for the x. Same thing for the x2, if these are quantitative. Once I get into gender, I'm starting, well, what proportion are males? What proportion are females? Then I expand my horizon. I start looking at, well, I wonder if body fat is related to gender. And I wonder if we can predict body fat from thigh and tricep and gender. So again, as a statistician, I don't care about all this left or right crap. I care about the up and down, and I care about, looking at the variables independent of each other, and then I want to look at the relationship across the variables. So hopefully, if I do my job, and I'm going to, and if you do your job as a student, and watch my instructional videos and let me recraft your narrative about statistics, then you too are going to see a data set like this. You ain't going to be reading left or right. You're going to be reading up and down, because that's where the relevant stuff is, statistically speaking. Now, let's move forward. I'm not going to get into this in this video. Well, obviously I'm going to get into this in this video. I'm not going to get into it in R until a video that's upcoming, which I haven't even created yet. But let's say that we have a categorical variable with more than 2 levels. And just as just a talking point, let's say we're looking at political affiliation, and whoever we are working with has defined political affiliation as Democrat, Republican, Independent, no affiliation. What we have to do there is we can't approach in a standard manner that we would with a dichotomous variable, this or that. What we have to do is we have to create a base comparison group. Second thing we have to do is we have to create what are called k-1 dummy variables. K is the number of levels, so we have 4 levels here. So k-1 is clearly 3. Sorry about that. So we would need to create 3 dummies. I would create dummy 1, dummy 2, and dummy 3. Assuming that my base comparison group is Democrat. Why did I choose Democrat? Because alphabetically it came first. The only thing. Now sometimes there's more of a theoretical nature to it. It may even be tied into your research questions. But I just did this for illustration. So my first variable, so to speak, is Republican-Democrat comparison. I call that my dummy 1. The next is my Democrat to Independent. Well, I call that dummy number 2. And my next is Democrat to no affiliation. That's what I call my dummy 3. When I transition into matrix operations, this is what it's going to look like. I'm going to create these 3 new dummies. This variable that I have like right here, which is party, which will have, again, reading up and down, we'll have Democrat, Republican, Independent, not a Democrat, they have all those listed here. is no longer used in my analysis. These dummy variables are used in the analysis. Now you might say, well, Dr. Darver, why are you teaching that now? Well, you got to trust me, okay? Even though the approach for a dichotomous variable isn't necessarily using dummy variables, it really is. So I'm going to inject that into when we transition into R. So anyway, my dummy variables would look this way. Again, I have 4 levels. I'm going to have 4 minus 1 dummies, 3. If I have a vector of zeros, that's what happens when I have a person who is Democrat. Well, you can't compare Democrat to Democrat. And again, a student once asked me, said, well, what if I want to compare Republicans and independents? I got to choose a different base. I can't compare Republicans and independents when I set Democrat as my comparison base group. So I would need to set another base comparison group and run a different model. So anyway, so what would Republican look like? Well, I would have a 1 under dummy 1 because my dummy 1 is comparing Democrat to Republican. Independent would have a 1 under dummy 2 because that's my Democrat to independent comparison. And my dummy 3 would have a 1 under NA for the same reason. Now, look, pump the brakes a little bit. Again, I say all the time, I don't get to stand up here and talk about statistics for a living without having been a student in many, many, many classes. I know this is confusing the first time you see it. It reminds me, I don't know if any of you have ever done the P90X circuit. I've been through it 4 or 5 times. And Tony Horton is the main guy. And he has many sayings, but one of them he says is, nobody said this is going to be easy, right? Well, nobody said that graduate level statistics is easy. There's a learning curve here, but just bear with me, and we'll build that together. So again, a preview of things to come, and again, I'm going to inject a little bit of this into the dichotomous situation, which I'm going to illustrate right now. All right. So let's do this. All right. I thought it was funny. Students entertain me. You guys just do. But I had I don't even know how much to say about this because I don't want to hurt anyone's feelings. But someone said something about they didn't like R, they liked RStudio, or they liked something else, whatever, because it took too long to do this. I timed myself. I typed all this in 40 seconds. So, all right, enough said. But anyway, I like RStudio, so if that's what you're using, it's perfectly fine. Now, what I want to do here is I'm going to predict, no, I don't know, we can do whatever we want to do, really, as long as we spell correctly. Let's do body fat from, I don't know, triceps and gender. So let's just focus on that model. So if I create my model as I would, I'm going to get this. So again, my tunnel vision goes to my predictors. Well, let's see the tricep. Again, what I have? Well, I have my estimate for the beta for tricep. I have my standard error, I have my test statistic, and I have my p-value. So I have statistical significance at the 0.001 level. Gender is using M as a comparison. So here I'm comparing male to female. So I can say for this estimate, controlling for triceps or keeping tricep constant. Male students, the predicted body fat, it's not male students, I'm on autopilot here. The predicted body fat for male is 1.8 higher than for female. Now, that's fine and dandy if I want to compare male to female, but what if I want female to be my base group? Well, I can easily do that just by changing the reference, okay? And I do that by restating gender, and I can just re-level it where I want my reference to be F's instead of M's. All right, so now when I run my model, notice that what happened here? Oh shoot, my bad. When it compared M to F, F was the reference, right? So what am I thinking? I'm losing my mind. So if I wanted the male to be the comparison, so if I want to compare females to males, so if I want gender F there, I can do this. Okay, there, I got it. So this is comparing females to males. So again, holding tricep constant, I can say that the predicted body fat for females is 1.8 lower than for males. Now, let's transition into matrix operations. So we should know now that we're on cruise control, I hope, that we would create our response vector. So we have body fat in row equal 20, in column equal 1, by row equal false. So we've got that, right? Next thing I need to do is I need to focus on my design matrix. Now here's where things get a little weird. When we're dealing with okay, let me make sure. Okay, when we're dealing with gender with M's and F's. Now, once we transition into matrix operations, for reasons that I've explained earlier, when we multiply matrices, when we do operations on matrices, we can't perform linear combinations on M's and F's. R doesn't know how to do that. Well, we can't even do that. We can't take 2 times F and 3, you know. So what we have to do is we have to convert the M's and F's to zeros and ones. Well, it turns out that's really easy to do. So I am going to do a recode of gender. I'm going to call it that. And I'm going to do an if-else statement. So if gender equal to, now pump the brakes. I'm going to go ahead and guarantee you that someone is going to use this if-else statement when doing their next assignment, and you're going to be doing it in the 11th hour, and you're going to put one equal sign there. It's not going to work, and you're going to flip out. You know how I know that? Because it's happened to me. So when it happens to you, you're in good company. It's happened to me. This command will not work if you use one equal sign. So if else gender. So what I'm doing there is I'm saying if gender is equal to female, then I want it coded as 0. Otherwise, I want it coded as a 1. So in other words, since we only have 2 options here, M's and F's, I am recoding my F's as 0, and anything that is not an F, in this case, by default M, I'm coding it as a 1. So I have my recode. I'm going to need my ones. What was the sample size here is 20, right? I forget. I know it is, but I don't want to. Okay, good. So I need to repeat, create my ones. So now I'm ready to create my design matrix. So we should know by now that my matrix is going to have C bind, it's going to have my ones. The next thing it's going to have is going to have the triceps, and then I'm going to have my recode gender. All right. Now, I know that my number of rows is the number of cases, and I know my number of columns is the number of predictors. Well, I have an intercept, I have my triceps, and I have my recode G. So it's really not the number of predictors. It's the number of unknown, or number of coefficients that we're estimating. I still see this as having two predictors, triceps and gender. So it's the number of predictions we're going to make. So now I know if I'm going to calculate beta, I'm going to take the inverse. Again, this should be tattooed to the brain by now. So I get beta, and I see I have a problem, right? Well, really, I don't have a problem, because if you see the 1.63 corresponds with the estimate for 1.63 and 1.78 and so on and so forth. So what I've done here, by recoding female as zeros, is I've let female be the comparison group. I'm going males to females. So anyway, again, nobody said it's going to be easy, right? It just depends on what the comparison that you want to make. And oftentimes, it doesn't really matter if you're comparing female to male or male to female. It just matters that you know what you're doing and you know what the output is telling you. So if you're doing some research, you can communicate it effectively. Well, not really effectively. You could communicate it correctly. All right, so we have our matrices all set up. We could go ahead and do some predictions. We can, there's all kinds of things that we can do here. And again, the beauty of it is the commands don't change from the simple linear regression case. All right, I think I'm sitting here second guessing myself, and I'm wanting to go on and show some more stuff, but I think I'm going to end the video here and call it a day. Have a good one.